A 300-meter crack has opened in a mountain above a Swiss village. Beneath it, an estimated 1 million tons of rock are already sliding downward. Investigators say the movement cannot be stopped. From the valley floor, the Alps can still look impossibly calm. Bright ridgelines, tidy streets, church towers, and pastures pressed against the snow. It is the kind of scenery that makes danger feel distant, as if beauty itself were proof of stability. But that picture may be the biggest myth in geography. Right now, one mountain in the Swiss Alps is breaking apart. Not slowly in some abstract geological sense. It is cracking above homes where people have lived for centuries. A 300-meter crack has opened in the mountain. It is not just a hole in stone. It is a warning line across a failing slope. Below the snow sits an estimated 1 million tons of rock. That mass has already begun sliding downward, and investigators say the movement cannot be stopped. Picture this for a moment. If the collapse begins, people below may have only 11 minutes. 11 minutes to leave the danger zone. 11 minutes between alarm and impact. The place under that threat is Brienz. It lies in eastern Switzerland, in the canton of Graubünden. The village stands 1,150 meters above sea level. For centuries, it occupied a gentle slope. Around it rose harsh mountain peaks. The setting looked stable from a distance. But local residents always knew one uncomfortable fact. The ground beneath them was never completely still. Brienz is effectively built on an ancient landslide. That old mass creeps toward the valley of the Albula River. For decades, the movement seemed manageable. The displacement was only a few centimeters per year. In this mountain region, that was considered normal. People adapted to it, almost as routine maintenance. A warped door frame could be corrected. A thin crack in an outer stone wall could be sealed. The village lived with small signs of movement. Those signs were familiar, not terrifying. Then the pattern changed. In recent years, nature began issuing warnings. These were no longer small inconveniences. The ground under people's doorsteps moved more visibly. The massive slope above residential houses began changing within one generation. That is the first evidence. A village used to slow motion met sudden acceleration. In the past, shepherds noticed occasional small stones falling high on the mountain. Now enormous blocks began reaching the edges of pastures. Some were comparable in volume to a passenger car. The slope surface changed too. It became cut by a network of new faults. Those faults widened quickly after heavy rain. They widened again after active snowmelt. Geologists then measured the change. Ground displacement had increased 10 times compared with the previous century. That figure changed the meaning of every crack. It turned daily life into waiting for impact. The most frightening signs did not always arrive in daylight. At night, after the village traffic faded, people heard a strange hum. Then came sharper sounds from inside the mountain mass. Residents described them as pops and loud cracking, like wood breaking but on a far larger scale. What does it mean when a mountain makes that sound? It means support is failing somewhere inside, and in Brienz, the damage was not hidden for long. Massive wooden beams began bursting in basements. This happened in old churches. It also happened under residential houses. The only road into Brienz showed the same strain. Its asphalt layer was torn apart. Strong ground tension beneath the surface pulled it open. Foundations began shifting relative to walls. In a single month, the movement reached several tens of millimeters. That is small on paper. Inside a house, it is a warning you can touch. Residents were trapped in a place where every rustle mattered. A sound from the mountain could mean the beginning of the end. Higher up, the landscape gave the clearest signal. Green meadows began turning into sharp stone piles. They also became scarred by deep sinkholes and depressions. Wells in the village began failing. Some dried up, others filled with muddy, dirty water. The cause was underground damage. Channels that once carried water through the mountain were being destroyed. So the evidence came from everywhere, from beams, from roads, from wells, from meadows. The slope was not simply moving, it was losing its internal structure. Authorities then installed special microphones near the settlement. Their job was to record activity inside the ground. The data showed continuous structural destruction within the mountain. Every recorded sound mattered. Each one meant another rock section had lost support. Each one meant another piece was ready to fall. Then the situation reached a critical point. Several hundred meters above the roofs, a huge ledge appeared. It consisted of rubble and boulders. It hung above the valley at a very steep angle. Only weak friction between rocks held it there. Observation with the naked eye was no longer enough. The unstable slope had to become a scientific testing ground. Scientists needed to know how much time remained. They already understood the mountain could collapse at any moment, so they moved quickly. Dozens of laser devices were installed on the slopes. They monitored every centimeter of the danger zone around the clock. Those laser beams can detect movement as small as 1 millimeter. Sensors were also placed at depth. They recorded the slightest tremors of the earth. Experts began living by the numbers. Every day, they checked how much closer houses were to destruction. Data reached headquarters every few minutes. At first, the displacement seemed insignificant. Then the values began rising. On some days, ground movement increased 2 or 3 times. There was no visible reason. On screens, scientists watched a disturbing scene unfold. Huge layers of earth, apparently motionless for thousands of years, began creeping downward. Each new report became more alarming. The process inside the rock could no longer be reversed. Then came the discovery that changed everything. During an aerial inspection, the 300-meter crack was found. It was a giant fault. It literally cut the upper mountain away from the main massif. That upper section now resembled a vast stone canopy. It was no longer properly attached. It hung above people's heads. Studies confirmed the fault runs tens of meters deep. Entire slope sections once considered safe began falling into it. The crack grew visibly. At that point, the collapse was no longer a theory. It was only a question of time. Engineers still examined rescue options. Could giant steel supports hold the mass? Could concrete barriers stop the fall? Initial calculations delivered the refutation. These methods would be useless. The rock mass ready to fall is too enormous. No wall can hold it. Trying to stop it was compared to stopping a speeding train with paper. That is the brutal engineering answer. The mountain cannot be braced into obedience. The only remaining tool is warning. Continuous monitoring became the last defense. Its purpose was simple: give residents notice before the final movement. Public address systems were installed in the village. Those loudspeakers were linked directly to sensors on the slope. Hundreds of lives now depended on electronics. The system had to work accurately in decisive seconds. A monitoring operator had to watch the screen around the clock. One calculation error could cost residents their chance to survive. That is not reassurance. It is survival reduced to measurement. Authorities then had to prepare hundreds of people for immediate flight. After scientists confirmed the mountain could not be stopped, Breens received red zone status. The red danger level meant immediate evacuation. Police established clear boundaries. No one could cross them without permission. Normal life ended instantly. Helicopters began circling constantly above the slope. Entrances to the settlement were blocked with massive concrete blocks. Evacuation itself became a major logistical challenge. Every family received instructions. Those instructions included an action plan. They also listed items for an emergency bag. Social services visited every house. They checked that people knew where to run. Rescue buses stood near the village around the clock. The preparation resembled a battle plan, but the opponent was the earth itself. Residents had only a few hours to pack their lives into bags. Then they had to lock their doors. For some, it may have been forever. Not everyone could accept that order. The psychological pressure was immense. These were people whose families had lived under the mountain for generations. One of the oldest residents became the clearest example. This elderly woman categorically refused to leave her house. She had lived there her whole life. She could not believe home had become a threat. While neighbors loaded cars, she continued household chores. Authorities spent many hours persuading her. Only then did she agree to leave. Her story exposes the human fracture behind the geological one. People can understand danger and still cling to place. Breens soon became a ghost town. Roads once busy with tourists stood empty. Lights no longer appeared in house windows. Children's bicycles remained abandoned in the streets. Garden swings stood without children. The only sounds were the hum of sensors. Occasional commands from rescue workers broke the silence. The abandoned atmosphere weighed on everyone entering the red zone. An entire region seemed frozen. Everyone waited for the siren that would announce final collapse. The danger area also grew. Forbidden zones expanded into new plots of land. Authorities blocked tourist trails as well. Any rockfall could trigger an avalanche. So the threat was not limited to one row of houses. It spread through the landscape. Now comes the central question. Why is this mountain failing now? Experts point first to melting permafrost deep inside the Alps. In the past, ice inside the rock acted as natural glue. It held huge stone blocks together. It prevented them from sliding. With general climate warming, that internal ice began turning into water. When ice disappears, voids form between rock layers. Those voids make the whole mountain structure unstable. Rainwater can then become the trigger. It penetrates the deep cracks discovered by scientists. Millions of tons of rock begin sliding over wet clay and sand. The movement becomes as slick as oil. The more water enters, the faster the slope moves. This is not one single cause. It is a chain reaction. Climate stress weakens the frozen bond. Water enters the cracks. Soft layers lose strength. Gravity does the rest. Geologists studied similar collapses in the region. The mountain structure here resembles a layered cake. Hard rocks alternate with soft rocks. Under pressure and moisture, the soft layers squeeze outward. That creates a domino effect. When one section loses support, it pulls others with it. Scientists compared Brienz with the collapse in Goldau. According to the source, that happened in the 10th century. There, a huge rock mass destroyed several villages within minutes. But the threat in Brienz may be much larger. Specialists now record movement not only on the surface, they also record it deeper than 150 meters. That detail is crucial. It means the upper soil layer is not the only danger. A huge monolithic piece of rock may fall. Nature is reclaiming territory people thought was theirs. Climate influence and geology have created ideal conditions for destruction. Experts are now calculating the final moment. What happens when friction finally disappears? How much energy will the falling mass release? How fast will the stone flow move? When friction between rock layers vanishes completely, the process becomes unstoppable. According to expert calculations, detachment will trigger violent acceleration. Within only a few seconds, the huge mass may exceed 100 kilometers per hour. This will not be an ordinary rockfall. It will not be stones rolling one by one. Scientists call it a rock flow. Giant boulders the size of multi-story buildings will collide. Those impacts will grind the mass into a thick mixture. Dust, crushed stone, and rock fragments will surge together. The entire flow will rush down the slope. Its path points directly toward the residential houses of Brienz. Computer modeling added another warning. The shock wave from that much falling rock may resemble a small earthquake. The main impact will strike the upper part of the settlement. Buildings there may be wiped away in moments. The debris path depends on the terrain shape, but the volume guarantees one outcome. The valley will be filled with rock several meters thick. Another piece of evidence lies deep inside the massif. Researchers found a hidden layer of soft shale. For years, that shale absorbed moisture. It became the slippery base beneath the upper stone canopy. Once the shale lost density, the 300-meter crack became through-going. Now the upper mountain is held mostly by its own weight. Several rock protrusions still help hold it, but those protrusions are breaking under colossal pressure. So the key number returns, 11 minutes. That is the evacuation limit after collapse begins. It is a critically short time to leave the dangerous zone. Sensors are set to the highest sensitivity for that reason. Any sudden change in movement speed becomes the signal. That signal means the final collapse has started. The world is watching a slope whose ending is set by physics. Every hour of waiting brings the outcome closer. Specialists understand the process has already begun. Humans can only record its stages. After the stones stop, the area will look completely different. Specialists believe most of Brienz may disappear forever under debris. Roads may be destroyed. Water pipes may be destroyed, power lines may be destroyed, even surviving buildings may not be usable. The land around them will remain dangerous. New rockfalls could continue. Living there may become impossible. The future of the area is therefore highly uncertain. Swiss authorities are already preparing plans for complete relocation. Residents may have to move to other safe places. That task is enormous. It requires large amounts of money and time. New houses will need to be built. New schools will need to be built. Jobs will need to be found in new locations. Brienz is not an isolated warning. Dozens of other alpine villages face similar conditions. Cleanup will not be simple either. Engineers say clearing millions of tons of rock may take decades. Heavy machinery on a moving slope is dangerous. Even vibration from equipment could trigger new collapses. The affected territory will likely be closed to visitors for many years. Specialists will leave instruments behind. Those instruments will continue studying how mountains break apart. The research can improve understanding of other peaks. It can also warn residents of neighboring valleys in time. The disaster will not end at the edge of the rubble. Mountain rivers may change course because of rock blockages. Changed rivers may flood other areas. Forests will face sudden habitat shifts. Animals will face them too. Scientists record that such events transform regional water systems. Water that once drained deep into soil may gather on the surface. That surface water may create new swamps. It may also create new lakes. Either result would make human return even harder. That is the wider footprint of a mountain collapse. It changes homes, roads, rivers, forests, and memory. The world is following Brienz closely for another reason. For the first time, this kind of mountain destruction is being recorded with great precision. Every early stage is being measured. Every acceleration is being logged. Every sound from the ground becomes evidence. The Brienz experience is considered extremely important. It can help create new safety rules for mountain countries. Specialists now understand that old risk assessments are insufficient. New assessments must include climate change. Those climate factors once seemed less important. Now they may decide whether a village survives. For residents, the disaster is not merely property loss, it is the disappearance of a familiar world. Many understand it as nature taking back its territory. The strongest rocks can break when internal balance is disturbed. That is not poetry. It is the conclusion written across the slope. Brienz is not just the tragedy of one small village. It is a case study in how fast the eternal can change. The 300-meter crack has become a symbol of that new reality. Modern instruments can measure the danger. Engineering calculations can define its force. But neither can hold back the mountain. A place that looked permanent now depends on sensors. A village that stood for centuries now depends on 11 minutes. And above Brienz, 1 million tons of rock are already moving downward.